From the beautiful studios of Way Happy, this is Mr. Meyer and 4 graphs of sine and cosine. Now, you didn't think you'd get away without graphing, did you? Because it's time to graph. Now, sine and cosine graphs are pretty easy. They are periodic graphs. That means that they just continue to repeat and repeat. And you might have noticed that the unit circle, or when you're doing these problems, as you rotate yourself around a circle, the same numbers just keep coming up over and over again. So what we like to do is on the x-axis, we like to put the angle. And on the y-axis, we like to put the value of sine. And then we can go ahead and figure out what's going on. So you'll notice a lot of times in math that we don't want to do on the x-axis, we don't want to do degrees, because to make it all the way around the circle, we'd have to go all the way to 360 degrees, and that would take forever. So let's go radians. Let's go from 0 to 2 pi. That's only 0 to 6. So not a real big deal. And you might notice that the y values, when you take sines, they actually never get bigger than 1. They never get smaller than -1. So they hang between -1 and 1, and that's why their range is between -1 and 1. Now, the big key to know about a sine graph is this. I'm going to plot it a special way where it uses 5 special points. And what those points are is after you mark off your tick marks, what you'll do is you'll mark out your period, whatever the period is, how long it takes it to repeat one cycle, and then it'll just continue that period over and over again. You'll mark it off, you'll cut it in half, and then you'll cut those in half, and then you'll do these 5 special dots. One will be at the middle of the graph, not middle left to right, but middle up and down. And then at the next tick mark, you'll go to the highest point of the graph. The next tick mark, the middle again, then the lowest point, and then the middle, and then the highest point, and then the middle, and you'll just repeat that pattern over and over again. So sine will always start at the midline, and then it'll go up to the highest, and then the middle, then the lowest, and the middle. And that's just a nice pattern to know. Now, cosine looks very similar, except its pattern, you'll go out to its period, which is 2 pi. You'll cut that in half, and then you'll cut those in half. And then what will happen is you'll start your dots at the highest point for cosine, and then the midline, and then the lowest point, and then the midline, and then the highest point at each tick mark, and you'll continue that pattern. And once you get through those 5 dots, life is pretty easy in the world of graphing sine and cosine, and a couple other tricks too. So let's talk about the different parts of the graph. You have amplitude. Amplitude is how tall the graph is from the midline to its highest point. That is what we call amplitude. So the amplitude, it's always found out front. It's like the multiplier. It's like the vertical stretch, right? It's always a positive number, even though it'll be written as a negative number. That just means flip the graph over the x-axis. But the amplitude, when you tell me how tall something is, you'll give me a positive value. And it's always the middle to the highest, or some kids like to think of it as the highest point to the lowest point is 2 amplitudes, one in each direction. So therefore, you could count the highest point and the lowest point, and then you could just cut it in half and tell me that's the amplitude. So the amplitude is the vertical stretch, how much you will stretch your graph. It's the multiplier to the whole function out front. And when you say it as a positive number. The period is multiplied to the x. So the period is how long it takes the graph to actually repeat itself. Right there in the red is one entire period. And then the graph is just that thing over and over again. It is more of like your horizontal stretch or compression. And so it depends on what's being multiplied to the x is what you will get. And so the way you actually find the period is you do a little formula, 2 pi over b is how you find the period. And then what you'll do is you'll graph that, and then you'll mark off your tick marks, and then you'll do your 5 dots, and you'll have a gorgeous, gorgeous graph. So let me show you a couple. Let me sketch this first one. So the first thing you should always do when you see a sine or cosine graph is you should see what that multiplier out front is. That's your amplitude. So you know how tall to make your graph. So I know the amplitude is 3. And the period is always the multiplier. So it's always 2 pi over whatever this b value is. There's your a, there's your b. Your b is what's being multiplied to the x. So in my case, 2. So it's 2 pi over 2. And now to sketch a graph, it's not too spooky. I will make my graph paper. I come out here anywhere I want, mark a little tick mark. Just mark it way out there somewhere and label that whatever your period is. Now my period is pi. So I'm going to mark this as pi. So whatever your period is that you calculated, you will mark it. Then you cut it in half. So half of that would be a half a pi. And then I'll cut those in half. And so that would be a quarter pi. So you'd have 1/4 pi and you'd have 3/4 pies. Now it's a good habit to do it in both directions because that's kind of cool looking. So I would just go out negative pi over here, cut it in half as negative pi over 2, and then cut those into quarter pies. And now you can do your amplitude, which is 3 units. So from the middle of the graph, 1, 2, 3, 1, 2, 3, and then you do your 5 magic points. Now remember that sine starts at the midline and cosine starts at its highest point or the amplitude. Watch out, if it's negative, it goes to the lowest point. So sine will start here at the middle. And then at the next tick mark, if it's positive, I'll go to positive whatever, in this case 3. And if it's negative out front, I will go to negative 3. And so I have to go to positive 3. And then at the next tick mark, it's midline. And then it's at its lowest point. And then it's midline. And you just continue that pattern in both directions. So if I'm going to work backwards now, the good habit thing, notice I'm going to go down. And then we go midline. And then next tick mark, I'm going to go highest. And then midline. And bam, here is a beautiful sine graph. Now, make your sine graph kind of curvy, right? Let's kind of go down and make it curvy. Don't make it jaggedy like shark's teeth, even though we love the sharks. We want to make it curvy. It's not a shark tooth graph. And that represents sine. And notice the x-axis represents your angles. Pi over 2 is 90 degrees. Pi is 180 degrees. And this would give you all the y values. If you plugged it into that equation, that's what you would get. And so isn't that kind of cool? That is my example of a sine graph. I can do the same thing with cosine. First thing I would do is figure out the amplitude, which is the number it's multiplied out front. So ours is 1/3. Our period is 2 pi over b. So in this case, 2 pi over, they're multiplying by 1/4. So 2 pi over 1/4, which through the magic of copy dot flip is 2 pi times 4 over 1, or what most people would call 8 pi. And so I get my graph paper out. And now that I know the period is 8 pi, I'm going to put a tick mark randomly out here. I'm going to put 8 pi. I'm going to cut it in half, which would be 4 pi. Cut that in half, which is 2 pi and 6 pi. I'm going to do it in the negative direction because I like to have good habits. So negative 4 pi. And it's just a graph that repeats itself. There it is. Now we have an amplitude of 1/3. So either I'll make this tick mark 1/3 or I'll make this tick mark 1, and then we'll just make sure that we only go a third up. And now I will do my beautiful graph. So it is a cosine graph, meaning it starts at its amplitude, either positive or negative. So it'll start at 1/3. Then at the next tick mark, it's at 0. Oops, I did 1, not 1/3. That was bad. It'll start at 1/3 and then at 0. And then the next tick mark, negative 1/3, and then 0, and then 1/3. And so that 5 patterns of dots, almost the same patterns as sine, except for sine starts at what we could call the origin. Now, midline, and then lowest point, and then midline, and then highest point, and then again a nice curvy graph to show everybody sine and cosine. So this is a cosine graph. Boom, there it is, my cosine graph. Nice. Now there's this thing called frequency, which you might want to know. Frequency is just how the number of cycles it creates. What it is it's the period flipped over. So if the period, like in the last example, the period was 8 pi, then the frequency would just be 1/8 pi, right? That's what we call the frequency. All right, let me give you a question and I'll be right back. All right, nice work. Now, of course, these graphs are going to be shifted. So we got vertical shifts, which just like any other function, here's your sine function right here. If I add something to it, moves the graph up. If I subtract, moves it down. So that is your vertical shift. All that's going to do is move your midline up or down. And so we just got to figure out what that midline is or what that horizontal shift is. So like on this one, if these are tick marks or by 1, I can see that the midline is right through here. And then it was up 2 units. So this must have been like a sine graph that had an up 2. And watch out, sometimes the book likes to throw that up in the front. And you might think that's the amplitude, but remember the amplitude is the multiplier. It is not what's added. So be super careful. All right, let's try a sketch of that. So usually it's not a big deal. I will again start off with figuring out what my amplitude is. In this case, what's multiplied up front. In this case is 1. I will then find out my period, which is 2 pi over b, which is what's being multiplied to the x. And in this case, it's 1. So my period is 2 pi. And then I will look for my vertical shift, which is whatever's being added on to the back. And in this case, a -3. So my entire graph will start off down 3. Or what I will do is instead of having an x-axis, I will draw a midline that is down 3 units. So here's my graph paper. And just like always, I kind of do the same kind of thing. I mark out the period. You don't have to. You could do that later. But I like to put a tick mark. Boom, period. 2 pi, cut it in half as pi. Cut those guys in half. I like to come out here. -2 pi. Cut that in half, -pi, and cut those guys in half. Now I like to draw my vertical shift in. So that's down 1, 2, 3. So my vertical shift, this is my new midline, kind of like my new x-axis. So there it is. Some people like to put their 2 pi and pi all on there, and that's fine too. But I like to put it on the actual x-axis and show that this thing is down 3 units. Now remember, your amplitude is how tall your graph gets, but it's not from the origin anymore. In this case, it's actually from the midline. So the highest the graph will get is right here at -2, and the lowest it'll get is right here at -4. Now, I've also in the past used dashed lines there to remind myself the graph lives between those lines, but you don't have to. But you might see later on that when these get a little crazy, that might be an okay idea. Well, now I'm ready to go. I've marked everything. I know where to start. So the only thing is I got to decide cosine or sine. If this was a sine graph, I'd be starting right there. But it's not. It's a cosine graph. So a positive one, in fact, so I'll go to the higher point, and there's the highest point of this graph. And then at the next tick mark, I'll go to the midline. And then the next tick mark, I'll go to the lowest. Remember, my pattern is just highest, middle, lowest, middle, and then highest, and then middle, lowest. Just continue that pattern. You can continue it in both directions so you get a beautiful graph. Oops, I went a little low there. And all of a sudden, I have a very nice shifted cosine graph. Here's my attempt at rounding these guys, and look at how beautiful. There is my cosine graph shifted down 3 units and having an amplitude of 1 and a period of 2 pi. Isn't that nice? All right, let's talk about a phase shift then, which is our horizontal left-right shift, and that's where it starts to get a little crazy, but a horizontal shift is called a phase shift. It, of course, has a multiplier to the x value, and most of the time, we may remember, just like before, you never want to talk about a shift to like a 2x. You want to talk about it to an x. So you always want to factor whatever that multiplier is out. And that could come into telling you what the right phase shift is. So be careful. So the phase shift is the opposite of what's being added or subtracted to the x. So here we have something added or subtracted. That is going to be our left-right shift. So probably right off the bat, if you just had to guess, you could probably already tell me the phase shift, that it is right pi over 2 units, and you would be correct. But here we go through all the motions, right? So I got amplitude, which is the multiplier out front, which is 1. I got period, which is the one that could mess us up a little bit. What's being multiplied to the x? In this case, just a 1. So it's going to be 2 pi over 1, which is 2 pi, our usual period. Our vertical shift is anything that's added onto the back, or watch out, it could be added to the front, and it's not. So there's nothing, so there's none. And then last but not least, our phase shift is there anything being added or subtracted to the h or to the x? And yes, there is. This would be a right pi over 2 shift. So if I'm going to go ahead and try to graph this bad boy, I'm going to go graph paper like that. I'm going to go, the period is 2 pi, so I'll mark off 2 pi and then pi and then cut those in half. And I'll do it in the negative direction because I like to. And there. And then there was no vertical shift, so the midline is going to sit right there at the x-axis, so that's cool. And I have the amplitude is 1 unit up and 1 unit down because the amplitude is in each direction. And now the goofy part, the phase shift. So this is a sine graph. And remember, a sine graph would always start right here at the midline, but we have to move it right, pi over 2. And how far is pi over 2? Well, we lucked out. Pi over 2 just happens to be one tick mark. So instead of starting our graph at this middle line here, it's going to start right here at that point because it was shifted right pi over 2. Well, now that we've done that, we can just do our pattern from this initial starting point. It's positive, so I'm going to go up. So at the next tick mark, I'm going to go up to the highest point, then the midline, then the lowest point, and I can go the other way. Lowest point, midline, highest point, midline, lowest point, and there is a beautiful sine graph. Now, somebody might notice that they're like, wait a minute. If I look right here, that looks like it's a negative cosine graph. And that's actually true. The sine graph and the cosine graph are so closely related that you can't actually tell if it's a negative cosine graph in this case, or if it's the sine graph shifted right pi over 2. They would look exactly the same because sine and cosine are so closely related. You notice that probably when you're doing your trig values, that they are very closely. They are exact same graphs, just one's shifted over. So that's the big trick there. But that's what it would look like. That's what a negative cosine graph would look like. That's also what a shifted sine graph would look like. So I guess we could do it all in one big step. We'll come back and we'll do that. All right, nice work again. Now let's wrap this up with the ugly, messy ones, right? What if they have everything? So you can see here, kind of a reminder. Here is the generic form of what we would call a sinusoidal graph, or a sine graph. Looks like this, right? It's got all these different parts, and you're like, oh man, that looks intimidating. But you realize you know each part as you do this. So it's not as spooky as it looks. The multiplier up front's the amplitude. B helps you find the period. It's 2 pi over B. And then H and K are your shifts, your vertical shift and your phase shift. So don't be too intimidated. One thing I do want to point out here in example 1 is, or this example, is that it might not be written that way when you first see it. It might be written as 4 cosine and then somebody distributes the half through. So they might have like x over 2 plus pi over 2 and then plus 2. And your job will be to go like, oh, I need to figure out the phase shift, right? And I can only compare the phase shift when it's to x, not when it's x over 2. So I'm going to have to factor out a half, and that's how I got that thing below it. So let's talk about what this graph would look like. Again, you're just going to go through the motions that I want you to do every single time, and that is tell me the amplitude, which in this case, what's multiplied out front? Up a 4. So it's going up 4, down 4 from the midline. The period is 2 pi over b. And now that we've done the factoring out, we see that our b value is a half. So that is 2 pi over a half, which is 4 pi. Copy dot flip if you need to. And then I got a vertical shift, means just what are they adding onto the back? And in this case, kind of obvious, they're adding a 2. So our midline is up 2 units. So if you want, you can write up 2, or you can write just 2. And then our phase shift is which way is it moved, left or right. And oh my gosh, look, it is left pi units. So, or some people will just say negative pi. So it's a lot to take in. That's a lot of transformations on one graph. So again, I'm going to graph this. Boom. Usually I catch myself doing, 4 pi, cut it in half is 2 pi, cut that in half is pi, and 3 pi. So there's my tick marks that I'm going to need for this graph. Now I will usually then do, after I do my period, I will then do my vertical shift, which we said is up 2. So 1, 2. So there is my new midline. That's where the graph is going to, take off from. And then I might even look at my amplitude now, which is 4. So from that midline, it's got to go up 4. 1, 2, 3, 4, and down 1, 2, 3, 4. Like I said earlier, sometimes when it's this far off, you'll catch me doing something like, hey, the highest points are up here somewhere, and the lowest points are down here somewhere. And so you can build your graph in between there. And so now I'm finally ready to start. Oh, I haven't done the phase shift yet, but I'm going to do it right now. This is a cosine graph. So cosine would usually start at its highest point or its lowest point if it was negative. It's our highest point, but I need to move it left pi units. Oh, thank goodness pi is 1 tick mark. Sometimes it'll be 2 tick marks. Sometimes it'll be half a tick mark. You never know. But I got to move that guy left 1 tick mark. So there he is at the highest point because of cosine, and left 1 tick mark. He looks like that. And now you just go to your pattern again. That's it. do your 5 dots. You've got the first dot. So moving right at the next tick mark, it should be at the midline. And then the next tick mark, it should be at the lowest point. And at the next tick mark, it should be back at the midline. And then the highest point. And then the midline. And then the lowest point. If I had to keep going, I can go in the other direction too. And I can say, holy macaroni, I have a gorgeous graph right here to create. And that, my friends, is a pretty difficult problem, right? That is a cosine graph that was shifted left 2 units, or left pi units. It's up 2. It's got a funky period of 4 pi and an amplitude of 4. That is crazy, but done well and done easily, right? And so that's what's kind of nice about these graphs. Now let's do one more. And then I think I'll save those other 2 for class, where you just write the equation. You can try it if you want. I'll show you when we get there. But let's do this last one because it's the first time I've actually had a negative number in front, so it's flipped over the x-axis. Maybe that will scare somebody or maybe not. So here we go. We got the amplitude, which we know is 5, because when you tell me the amplitude, you tell me it's a positive number. You tell me the period, which is 2 pi over the multiplier. So in this case, 2 pi over 3. That's our period. Ooh, that's going to be scary. We got a vertical shift of -1, and we have a phase shift of nothing. There is no phase shift. That's nice. So now I'm going to come out here, get my graph paper. Again, going to mark off my period as 2 pi over 3. Now you might be a little scared. What's half of that? Well, that would be 2 pi. Now multiply top by 1, bottom by 2. So 2 pi over 6, or what most of us would call pi over 3. Cut that in half as pi over 6. And if you need to know this tick mark, you add those first 2 together. That tick mark is just those first 2 added together. So what is that? If I would make this 2 6, it would be 3 6 altogether. So that's a half. So pi over 2. So there are your tick marks. And this way, -2 pi over 3, negative pi over 3, and then the other 2 tick marks. My midline is down 1. So it's down 1. So there is my new midline for this graph where I'm going to build everything off of. And then I will do my amplitude is up 5 from that. Yuck. 1, 2, 3, 4, 5. That's as high as it'll ever be. Up here at the number 4. And the lowest it will ever go is 1, 2, 3, 4, 5. Here's the lowest that graph will ever go at -6. And now I'll do my dots. Luckily, there's no phase shift. So this was a sine graph. So sine graphs start right here on their midline. That's nice. But look at the first tick mark. Usually I would go up to the highest point, but because it was reflected, I'm going to go down to its lowest point. I'm going to do a little backwards. So negative, and then midline, and then highest, and then midline. And going the other way, let's see, it went low there and then mid. So it must be high here. And then it must be mid, and then it must be low here, and then it must be mid. And there's this gorgeous, oh, that's a little shark toothy looking sine graph that has rounded curves, beautiful, and I am golden. I am feeling very nice. All right, you can see the bottom of the screen there. You can go ahead and try to make a sine graph if you want with those phase shifts and that vertical shift and everything and that period. See if you can get it. And we'll try it in class. Have a great day, and I'll see you tomorrow. Stay happy.